For like the question, CSFs, what the openings. I understand the research are also. Not many, they're not pushing hard. Who's on TSF? I mean, does Bruce be?
Yeah.
All right, guys. Welcome back. Hope you guys had a nice break. I'm still in the process of grading your recent quizzes. Hopefully, I can have that in Wednesday or Thursday, and I'll be able to put that in the grade book and return it back to you. So we're starting our unit on stats. This week, there's no assessments. We're just going to be going through the notes. This is the last page of your packet. So if you go to the last page, the calendar is on the second last page. On the last page has a list of useful formulas that we'll be using over the course of this unit. So I feel like you've seen probably a lot of this already. Mean, median, mode, variance, standard deviation. I think a lot of this was covered in Algebra 1, but we're going to go back and review a lot of this. So normal distribution, I feel like a lot of this should feel like review. We'll have a check-in quiz next Wednesday. And then I think the thing that will feel new won't show up until next Thursday. Confidence intervals, we'll go through that next Thursday and Friday. We'll review the following Monday and Tuesday. And then tests will be on the 27th. However, now that we know that this is part of the EOC schedule, all the time periods, all the class periods will be like 30 minutes or less. So right now that I'm looking at it, we may split it into 2 days. So we'll see, but hopefully we can get. It's going to feel weird this week. Every day is going to be all the class periods be cut short because the first like 2 hours, 2.5 hours will be EOC is going on. So it'll be a late start for all the periods that week. Okay, so I'll come back to this and let you guys know exactly what we decide on. Okay. After this, we only have 2 more units. We have logarithms, and then we have function analysis, which is review of graphs of functions. And that should end the unit. There's no final exam for this semester. So we have a couple tests and quizzes remaining. There's no EOC for this course, and there's no final exam for this course. I think EOC is only for 11th lit, bio, algebra, and geometry. Okay, so let's go to page 4. The page 2 and 3 is a probability table. We'll use this as we get to it. I'm sorry, 11th lit, bio, US history, and algebra 1. 11th lit will be Monday and Tuesday, bio Wednesday, US history Thursday, and algebra 1 Friday. Okay, so you've seen this before, mean, median, mode. So let me go through these formulas here. So mean is just finding the average of all the numbers, right? So you're going to add up all the numbers and then divide by however many numbers you're using. So that's what this X bar means. X bar, it just means the average. And the summation X, all this means is that you're adding up all the numbers, and then you're dividing by however many numbers you're working with. Okay, so it's just add up all the numbers. That summation just means the sum of all numbers or all the values. And n is the number of terms. So it's like, if you want to calculate the average of all your tests, you can add up all your test grades and divide it by however many tests you've taken, and that'll be your average, right? Okay. A median is the middle number when the data is arranged in ascending order. Okay. If there are two numbers in the middle, then you find the average of those two numbers. So quick example here, if I have 1, 2, 4, 9, and 100, what's going to be the median of these 5 numbers here? 4, right? 4. But what if I had 1, 2, 4, 6, 12, 15? Yeah, so if I have an even set of numbers, if there are two middle numbers, then I take the average of those two middle numbers. So the median is going to be 5. Mode is a number which occurs most frequently. There does not have to be a mode, and there can be more than one mode. So the number that recurs most frequently, I think we only consider this if it's more than one, right? So if every number appears just once, then there's no mode. Only if it starts duplicating, then like bimodal will have 2 modes, trimodal will be 3 modes. So for instance, if I had 1, 1, 2, 2, 5, 6, I'll have 2 modes, right? This is bimodal because I have 1 showing up the same number as 2's. There's 2 of each. So there's 2 modes here. 3 modes will be like 1, 1, 2, 2, 5, 5, 6, right? And we only consider the ones that are occurring the most frequently. So if there were 3 ones, then there's only 1 mode, right? There's only 1, because 1 is the number that appears the most often, more than any other number. Okay, so if you have your calculator, we're going to practice finding mean, median, mode for these set of numbers here. Okay, there are 15 scores, so n is 15. The mean, I'm just going to add up all these numbers and then divide by what? 15, yeah. We'll round to 2 decimal places. If I want to find the median, I first need to put all the numbers in what? Yeah, in ascending order, right? So think I missed the number. Missed the number. Oh, there's two 89s. Okay.
For the mean, what you want us to ask?
Yeah, to 2 decimal places. So you can either drop that last number because it's 466. You can make it either 46 or you can make it the third number round that's 6 or 7. So either is fine. You can do 46 or 47. They're both good. 83 is median. Okay, what number occurs the most often? 80, yeah, so this is bimodal. There's a tie for number that's repeated the most often, so we include both numbers as the mode. 83 appears twice, 89 also appears twice. Okay, let's see. Okay, next up, 5-number summary is where we're looking for 5 numbers that come from our list of from the scores that we have. So we have the minimum, which is the lower extreme. That's the smallest number. We also have the Q1, lower quartile. This is going to be the median, so it's going to be the middle number of the lower half. And then, so the Q1 is going to come from the bottom lower set of numbers. We're not going to include the median unless the median is, we have to find the average. If the median is not in the list, then we'll include that number. But here, Q2 is going to be the median. And Q3 is going to come from the upper set of numbers. And then the maximum is going to be the largest number. Okay, so let's start with the smallest number. The minimum is what? 32. Q1 is the median of the lower half. So we're going to find the middle number out of these sets. If we, looks like we have an odd set of numbers, so we should get a middle number here. So middle number is going to be 74. Oops, sorry. Median is Q2. Q3 is the upper quartile. It's the median of the upper half. So count down. Middle number is that 89. And then the maximum is 100. Okay, next page. We also have something called the box and whisker plots. This allows us to get a visual feel for the numbers that of our five number summary. The plot that displays a 5-number summary. So from the previous page, we found 32, 74, 83, 89, 100. So we're going to draw a number line and scale it appropriately. Keep the minimum and maximum in mind. So I'm going to scale it as best as I can. So we're extending from 30 all the way, 32 to over to 100. So let me just see if I can mark off 30, 40, 50, 60, 70, 80, 90. Okay, so 32 is going to be your minimum. Your minimum and your maximum is going to be where your whiskers are going to extend to. And then the box is going to be surrounding your Q1, Q3, and median. Okay. So 32, we're going to estimate where 32 is. And we're going to extend to our Q1. Q1 is 74, so I'll put 74 around here. Median is 83. Q3 is 89. And then the largest number is 100. Okay, you'll put a box around your Q1 to Q3. This is kind of like where the majority of your data is going to be. And then we can visually see what the highest and lowest values are. So it looks like this is an outlier, right? This is the majority of students are not down here at 32. Majority of students are up here in the passing range. Okay, so what we did was we placed the points above the number line for each number in the 5-number summary. We connected the minimum and Q1 with a segment, as well as Q3. And then draw a box around Q1 to Q3, and we draw vertical segments through the median. Okay. Now the shape of box and whisker plots. Go over those as well. So if there's symmetry, meaning that your mean and your median is going to be the exact same, then we call that a symmetric box and whisker plot. So your mean is equal to your median. Here, skewed left is where your median is, sorry, your mean is less than your median. So you expect the mean to be somewhere in somewhere around here, right? And the median, the middle number, is all the way up here. So that means your average is going to be less. And we call it skewed left because we see a longer whisker on the left side. Skewed right is where the whisker is longer on the right side, and this is where your mean is greater than your median. Your average is more than the middle number. So that means you're going to have, yeah, that just means that your number, most of the data is here, but then you have one or two people who are scoring much higher than the average of your of the students. Okay, a couple more things here. Range is the difference in the maximum and the minimum value. So range is just the highest minus the lowest value. So let's find the range. What numbers are we going to be looking at to find the range? Yeah, 132, right? So range here is just 100 minus 32. $68. IQR is the difference in the upper quartile minus lower quartile. So this is Q3 minus Q1. So we know Q3 from the previous problem was 89. Q1 was 74. So Q3 minus Q1 is going to be your inner quartile range. Okay, 15. Okay, mean absolute deviation. This tells us how spread out our numbers are. So it takes a little bit, not difficult, but it does take a little bit of time and space to work through. So I'm going to use the rest of the space here to help us get there. So what this means is that we first have to find the average, which is our mean. So our mean from the previous was 79.47. Okay, let's use that number. I know some of you may have used 79.46, but we'll use 79.47. What this is saying is that every number, every test score, you're going to subtract it with the mean. And whatever number comes out, you're going to create the positive difference between them. And then you're going to add up all those numbers and divide it by 15. Okay, so let me show you what that looks like. It's a little tedious because of all the things we have to do. But I'll make a couple of columns here. Let's see. So I'll use the numbers. I'll go down the list here. Doesn't have to be in order, so I'll just take the first number that I see, which is 90. My mean is 79.47. And the difference, I'm just going to subtract it and find that decimal value. Which is 10.53. We're gonna do that with every one of the 15 numbers, right? We're gonna just subtract. And if we get a negative number, we'll just make it positive. Okay. If we get a negative, just make it positive. So all we're doing is taking every number and then subtracting it from 79.47. A9 minus 79.47. Again, if you get a negative number, just make it positive. Okay. We're subtracting from 79.47 for all of these. Let me zoom out a bit to see it. Okay, so now using all these numbers, we're going to add all these numbers up. The only numbers we care about now are just these here. That's what this formula is saying. We're going to accumulate all the differences, the absolute value of the differences. So for instance, here, 32 minus 79 may give you a negative number, but you're going to change that to a positive 47. We're going to add up all these numbers, and we're going to find the average of all these numbers. So all these numbers added together will give us 144.65, and we're going to find the average of the spread between all our test scores. So the mean absolute deviation is 9.64. So it tells us on average, students are scoring 9 points away from the mean, which means that it's kind of spread out, right? We have students scoring all the way down. The spread can all the way go from 32 to 100. So if there's more consistency, then your mean average deviation will be smaller, right? But if you have a wide range of test scores, then your mean average deviation will be a larger value. Okay, any questions with with how to find mean average deviation. Sorry, mean absolute deviation. Okay, example 2. Hey, let's just all use the same number so that we can kind of just go through this together. It says list the number of pets from 8 of your classmates. Let's just use the same numbers here. So I'll just pick 8 numbers for us to use. So we'll use these 8 numbers here: 1, 1, 2, 2, 2, 3, 3, 7. Let's see how we do here between B and D. Calculate the measures of center, the mean, the median, the mode, 5-number summary, and then create your box and whisker plot. And then also find the range, IQR, and mean absolute deviation. Oh yeah, up here. Sorry, my bad. 1, 1, 2, 2, 2, 3, 3, 7. Okay, so again, mean just means add up all the numbers and divide it by 8. Median, everything's already in order, so just find the middle number. And mode is number that repeats the most often. Okay, feel free to use your calculators. And the shape is either symmetric, skew left or skew right. The way you can tell, don't look at the box, look at the whisker. Okay? Whichever has a longer whichever side has a longer whisker is going to be which side is skewed towards. Make sure that your x minus x bar are only showing positive numbers. If you get a negative number, just convert all the differences to be positives. So we're going to add all these and divide by 8. Oh, I messed up here. 3 minus 2.6. My bad, 0.37, my bad. These are wrong. Try again. There, it's better. So best measure of center and spread. If you have a nice symmetrical graph or a list of numbers, then the mean absolute deviation is going to be good to figure out how how to measure that spread. But if things are really off, where you have a clump of numbers that are, or you have a lot of outliers that's kind of throwing your data off, then using interquartile range will kind of get things a little bit more, will give us a better idea as to how spread out the data is. Because sometimes if you have a number that is way outside of most of the numbers, it can kind of throw off your data a little bit. So, but if numbers are pretty evenly distributed, then mean absolute deviation is good. But if you have numbers that are way to the left or way to the right of most of your data, then median and IQR gives you a better sense of the spread of most of your numbers that are close together. Okay, we're just going to practice page 7 and 8, and we'll just try to get through as much of this as we can. Okay. So we're just practicing through these concepts here. Okay, page 7 looks like all these numbers are already in order, so that makes it a little bit easier. Okay, does anybody still need this page? Okay, add up all the numbers divided by 13. That'll give you your average home run distance. Mean absolute deviation is going to be a chore to go through 13 numbers. So let's do mean absolute deviation for the second page, page 8, when there's less numbers. So right now you can just copy that down. Okay, Bosk and Whisker plot here. And right now, just know that outliers are numbers that are way outside the majority of your numbers. We'll talk about a little bit more about how to find the outliers in the more formula based, but right now you can tell that 457 and 461 are clearly outside or furthest away from the majority of your numbers. So okay. Okay, let me go through any questions with number one. Okay, let me go through number two, a few minutes here. Suppose that the number of unnecessary procedures recommended by 5 doctors in the month are 2, 2, 8, 10, and 18. If we ask a 6th doctor and they recommend 35 procedures, how will that affect the median and mean? So you see that that 35 is way outside the majority of these numbers here. And let's find the mean and median for both sets, for the 5 doctors and then for the 6, including the 6th doctor. Okay, just to save some time here, X bar is the mean. If I add up these 5 numbers divided by 5, and then for the 6 doctors, the mean is going to shoot up to 12.5. The median will go to 10. So we see that the mean and median will both increase. But the mean is going to be more impacted because that 35 is going to push that number out a lot more. So if you have outliers, it's going to impact your mean a lot more than your median. Your median will stay, it's kind of the middle number. So if there's a lot of outliers, it's not going to push the data out too much. And that 35 is going to create a large whisker on the right side. So let me skew to the right. Okay, how will IQR and a mean absolute deviation be affected? If I just look at the first 5 numbers, IQR is 8, mean absolute deviation is 4.8. If I include that 6th doctor, IQR will go up to 16. Mean absolute deviation will also jump. So you see that that 35 is really pushing both these numbers to double, right? So both. Okay, let me check your pages 5, 6, and 7. We'll finish up page 8, but we'll also start 9.02.